So if you want to write a set, you might say the set is A. So we call it A or B or any capital letter really. We use capital letters. We could call it F if you want. And let's say we have some set, we call it A. We can say that it's equal to this curly brackets. So we've got curly brackets like that. And then the things in the set, the elements of the set, we can separate with a comma. So we might have 1, 3, 7, 28, whatever. And that's a set. So you're in curly brackets and we call it a capital letter. The union of two sets, so we have A and B, these are sets. The union we write as a big kind of U shape. And what this means is it is all of the elements in A and all of the elements in B. So if you want to draw it like a Venn diagram, so we might have a Venn diagram like that, and that's A and that's B. And the union of A and B is simply everything here. So everything that's in A or in B, and it can be in both as well. The intersection of two sets, A and B, is written like an upside down U. So kind of like a N, but not really. That's like an upside down U. So the union, but upside down. And that is the intersection. What does that mean? Well, let's bring our little Venn diagram back. The intersection of this A and B is the region where they overlap, where they intersect, if you will. So just this region here, which means that the things, the objects in the intersection of A and B are all of the things in A and in B. For subsets, if we want to say that C is a subset of, say, A, we write it like this, like a kind of C shape with a line underneath. And then what that means is that C is either a subset of A or C is equal to A. And what do I mean when I say subset? Well, let's have a look at a diagram. So let's say this is a set A. Now, a subset is any set which is enclosed in A. So I've got C in A here, and everything that's in C is also by definition, or by construction even, in A. So that's what we mean by a subset. But C can also be equal to A, so you could have A, and you could have the same thing of that. Let's just pretend that's the same, and that's C as well. So that still counts as a subset, even though it is just the same set. If it's like this and it's not the same set, then we say that C is a strict subset of A with no line underneath. And finally, if we want to talk about the individual elements of a set, we say that, okay, let's take this set over here, A. So write A, which is just 1, 3, 7, and 28. And I want to say that something is an element of A, then I say that some element X is an element with this little, it's like a C with a line in the middle, kind of like an E, if you like, E for element. That's the way I like to think of it, and that's in A. So X is in A, X is an element of A, and in this case, the X's are just 1, 3, 7, and 28. So we could say, for example, 7 is an element of A.